Okay, so on this page note, we are going to talk about actually coming up with the polynomial based on the zeros that it has. So in number 7, it says if a function has zeros of 4 and negative 2/5, we are going to write a quadratic equation that has a negative leading coefficient with these zeros written in what they call factored form, which is actually easier. I like factored form because we don't have to do as much work as if we were asked to do standard form, which is actually part B. Okay, so we know that if we have zeros of 4 and negative 2/5, that's x equals 4 and x equals negative 2/5. Okay, and so what we're going to do is we're going to take those solutions and think about what their factor was before they became those solutions. And so if we have x equals 4, the factor that we had before was x minus 4. And the other one is a little bit harder to come up with because of the fraction, but you have to remember to undo the divide by 5 that you're going to multiply by 5, and so we'll end up with 5x. And the opposite of that minus 2 on that side, if you add the 2 back over, will be a plus 2. Okay, and we are equal to 0. The one thing that they have to still do is talk about that there's a negative leading coefficient, so we need a negative out in front to distribute to get that negative leading coefficient. And there's our equation in what we call factored form. Okay, but in part B, they want that same equation that has that negative leading coefficient, but written in standard form. So what we're going to do is we're just going to go ahead and put these factors back together. All right. So what I like to do is I like to hold that negative there and put these back together. And you could do it with the box if you're more comfortable doing it with the box, or you can do it with the rainbows. It is completely up to you how you want to put these two factors back together. All right. But if I fill in the box, we end up with a 5x squared minus 20x plus 2x, and then a minus 8. And so these two terms here in the middle there on that diagonal are combinable. And so we'll go ahead and say negative on the outside. We'll have to distribute that negative in. But right now we have 5x squared minus 18x minus 8 equals 0. And now we'll distribute that negative back in. So we end up with our negative leading coefficient of negative 5x squared, and then plus 18x, and then plus 8, and equal to 0. And that is what they call standard form. Okay, there's no parentheses in it. Everything has been distributed. And our exponent or our terms have been ordered with the largest exponent term going first. Okay, and there it is. Okay, so we'll go ahead and take a look at another one in number 8. And in number 8, it says that we have a function has one root at negative 1/4 and a double root at negative 3. And we want to find an equation expressed in factored form that has these roots. And so what we're going to do is remember that roots are what x equals. And so we end up with x equals negative 1/4. And we have what they call a double root at negative 3. So we'll have x equals negative 3 and another x equals negative 3. And we're going to take those solutions and we're going to turn them into factors. So the first one is the hardest because it's a fraction. And so we have to remember to undo the divide by 4 by multiplying by 4. So that turns that into 4x. And then the opposite of that minus 1 is plus 1. And so that's what the factor used to be before it became a solution of x equals negative 1/4. The other two are a little bit easier. X equals negative 3 used to be an x plus 3 as a factor. And nice thing is it's a double root, so it'll have the same exact factor again. All right, don't forget your equal sign because they're asking for an equation. And there is our equation in what we call factored form. Okay, they didn't say anything about the leading coefficient, so that's why we didn't put a negative out in front like we did in number 7. And now in part B, they're asking us to express that same equation, but in standard form that has those same exact roots, so same exact factors that we have from part A. We just have to put them all together. All right. And remember, it is impossible to multiply 3 things at once. And so we're going to multiply 2 of them, and then we'll throw in the third one. So again, if you are a box person, you might want to set up your box. And I'm going to actually put these two, the 2x plus 3's together first, because that is easier to do when they're the same. And so we'll put the x plus 3 multiplied by the x plus 3 together first. And when we fill in the box, we have x squared plus 3x plus 3x plus 9. And those will go again together. And so we will have that 4x plus 1 still out in front. And we will now multiply that by x squared plus 6x plus 9, and we're still equal to 0. All right. If you want to create another box, you can. I'm going to create my box down here. However, guys, it has to be a 2 by 3 in that we have a binomial of the 4x plus 1 being multiplied by the x squared plus 6x plus 9. Or you could use the rainbows Okay, it's completely up to you. When we fill in this box, we're going to have a 4x cubed plus 24x squared plus 36x. And then we're going to have an x squared, positive x squared, a positive 6x, and a positive 9. Okay. And when we go ahead and write that, our highest exponent is the 4x cubed, so that'll go first. We have two x squareds. We have a 24x squared and a plus x squared, which is plus 25x squared. And then we have a 36x and a 6x, which is a positive 42x. Okay. And then our plus 9, and don't forget we need to be equal to 0 so that this is an equation, and there is our polynomial that would have 3 roots. All right, so notice 3 roots, and the highest exponent is 3, so that makes sense. All right, let's take a look at number 9. And in number 9, it says that if x minus 1 is a factor, then what is the value of k? And so we're going to get more into this later in our Unit 10 notes. But what we have to realize, guys, is that if x minus 1 is a factor, then x minus 1 equals 0, and x would equal positive 1. And knowing that x equals positive 1, we're going to replace all those x's with 1, and then we'll be able to solve for k. All right, and so this is going to be 1 raised to the third minus k times 1 raised to the second plus 2 times 1. Now, if we want to figure out the value of k, that means k equals, and right now we don't have an equal sign, so you have to remember, because they're talking about factors, okay, and solutions, that this is equal to 0. Okay, and if we replace that, then we'll be able to solve for k and get k equals at the end, because now we have an equal sign. All right, so 1 to the third is just a 1. Minus k times 1 to the second, which is just a 1, plus 2 times 1, which is a 2, equal to 0. All right. Right here in the middle here, negative k times 1 is negative 1k, or just negative k. And so I'm going to go ahead and replace that, so it makes it a little bit easier to solve. All right. I'm going to also combine my like terms here. I have a 1 plus a 2, okay, which is 3 minus k equals 0. And then I'm going to add my k to the other side, so that I end up with 3 equaling k. And now I have finally solved for k, and it's choice 3. Okay, so a little bit tricky, but we're going to work on that later on in the packet as well. And last question, guys, number 10. It says, which description could represent the graph of f of x equals 4x squared times x plus a minus a, where a is an integer? All right, so this gets a little bit tricky with the a's in there. But if you think about it, guys, those parentheses usually aren't there, and so we're going to get rid of them so we can see our equation without them. And if we distribute here, we're going to get 4x to the third plus 4x squared a minus x minus a. And I wanted to do that so you guys could see that the highest exponent is 3. All right, and the highest exponent being 3 means that it's going to have 3 roots. All right, and you have to remember that roots are also known as x-intercepts. So it's going to have 3 x-intercepts. And so if you look at choice 3, it has 4 x-intercepts. If you look at choice 4, it has 4 x-intercepts. And so 3 and 4 are gone just by knowing that the highest degree of this polynomial is a 3. Okay, so we want to keep choice 1 and we want to keep choice 2. Now we got to figure out the difference between choice 1 and choice 2. And so in choice 1 and choice 2, the similarities is that this says x approaches negative infinity, x approaches negative infinity, but this is f of x approaches positive infinity, and this is f of x approaches negative infinity. Okay, but this last part here is the same. X approaches positive infinity, f of x approaches positive infinity. And so we have to figure out what is the end behavior of our graph. Okay, and so if you remember what we talked about, with an odd degree, odd degrees will have opposite end behavior. All right, and you guys can see that in this one, choice 1 has same end behavior. Well, same end behavior goes with an even degree. And remember what our degree is, it's a 3, it's an odd. And so choice 1 is going to be out, and choice 2 we're going to keep. All right, because right here, that f of x approaches positive infinity. This f of x approaches negative infinity, which is an odd degree because it is opposite end behavior. All right, so our graph would look something like this. Okay, where we got opposite end behavior, we had a positive leading coefficient, and so it ends going up or in the positive direction. All right, so a little bit tricky, but ruling out using process of elimination will help. All right, guys, I'll see you guys on day 2 notes.